Hello, everybody. I am John Richardson, and this is my co-host.
I'm Mike.
Mike Johnson. And Mike Johnson, yes, and we're here for channel 76, wasn't it? 74. Channel 74 news. You know why do you always have to correct me on TV? I'm probably going to lose my job because of this. We're back, folks, to inform you and everyone watching about what evolution is. Mike, my co-host, do you know anything about evolution?
Charles Darwin is the father of evolution.
Good job. What you don't know about evolution, and most people don't know this, is Frederick Wallace wrote a similar theory of evolution, and independently from Darwin, they were completely separate and didn't even know each other, and but once the two got together, Frederick Wallace's theory was a little more accurate and more clear, and he humbly let Charles Darwin take all of his work and become, famous for it, and Frederick Wallace never really got any of the credit.
They were made at the exact same time.
Speaking of evolution, we actually have a reporter, what's his name?
Larry.
Last name?
He doesn't have a last name.
No last name.
Nope.
He's a very strange man. Anyways, where's he going to be reporting from?
From our backyard, because this is fake.
Oh, really? Maybe a low budget, maybe it's just science project. Maybe we want to get A at the end of the year. Who knows? Yes, he is going to be talking about Charles Darwin and an interview with him. How about that?
Hi, I'm Larry, and I'm supposed to be here with Charles Darwin, but he could not make it because he is dead. Many people think that Charles Darwin was the first creator of evolution, but he really wasn't. A man named Robert Chambers actually had the same theory before him, and he published it before Charles Darwin. But the thing is, he didn't have as much evidence that Charles Darwin had. So Charles Darwin eventually got more evidence from Alfred Wallace, which helped him and gave him all the credit. So in the end, Charles Darwin got all of the credit for it.
We're back, folks. Larry, yes, a very odd man, as we said before.
Very strange.
Yeah. So I hope you enjoyed his interview, everybody.
We actually are unsure about his gender.
Yeah.
Only the best make our famous 2 for $20 menu, like the new creamy Cajun steak and shrimp shrimp pasta. A great deal for game day or every day. See you tomorrow.
Hello, everybody. Back to evolution. So now you just found out who Charles Darwin was, and
Found out about his past career.
Yes.
No one likes him.
Just like that Kyle kid. Kyle Carey, I don't know.
We interviewed him once at that Fox 8.
Fox 8, cool school? I don't know.
They picked the biggest loser to interview.
I really don't think he had many friends, if any at all.
He was just staring at that one girl.
Yeah. Hello, everybody, again. I'm getting pretty tired of saying hello. We should just stick to this. I know. Just touch it again.
Script.
Evolution is a very slow process that takes place over many, many generations and is driven by natural selection. We'll get into natural selection a little bit later. But evolution is, we pretty much explained it back with the Charles Darwin interview. But again, as we said, it takes place over many, many generations, a very long time, and it's the changes that happens throughout in mutations of different species and how they end up.
Like dinosaurs?
Dinosaurs. The little tic-tac-toe game right next to it also.
It's just
unfinished.
Scripts.
Paleontology, the study of ancient life using fossils, evolutionary change documented in the fossil record. Life evolves from simple to complex in the fossil record. We all started out as very tiny single-celled
almost
organism.
like dinosaurs.
Dinosaurs, yes.
I like dinosaurs.
Yes, he does. It's okay. So, like I said, single-celled organisms. Oh, I'm sorry. Single-celled organisms, and eventually they began to split and break up into.
They turn into
Dinosaurs again. Dinosaurs. Started to break up into different cells, okay, and maybe more complex and maybe more than one cell. It was a multicellular organism, and eventually they became very complex, like to form little bacteria, and then eventually insects and dinosaurs again. Yes. Wait. Dinosaurs in a little bit, okay? I'm getting to it, okay?
Okay. Just sorry.
God.
Sorry. I go to therapy.
We both do. Together.
Um,
Okay. Anyways.
and the next subject is biogeography. You can do the rest.
Thank you. Biogeography is the geographic distribution of organisms. The similar organisms with very minor variations that are found near each other instead of randomly across the planet. Like dinosaurs. How about that?
Thank you.
Yes.
Involves
It's
dinosaurs.
okay.
Okay.
Okay. I'm sorry. Script. That's right. I gotta stick to the script. Okay. Biogeography is that when there are a bunch of organisms, and when maybe even through paleontology, when they study the fossils or just look at the evidence of those organisms, they find that the very little variations through the species are found very close to each other. Wow, the camera's moving. Bye, guys. And that the variations in between the species will be found. The species will be found very close to each other rather than on the complete other side of the world, because it makes the most logical sense. The next main evidence of evolution is comparative anatomy. Would you like to go over that?
That's okay.
Are you sure?
Does it involve dinosaurs?
It might actually.
No, it doesn't. Then go.
Oh, it doesn't?
No.
Okay. Comparative anatomy is when you take two organisms and you compare, like, the anatomy of them, or you compare what they're made of, such as a bird and a bat. Not the one you swing in baseball, the other flying bat. I know, the baseball bat, it looks a lot like a bird, like it flies and stuff, especially when people get mad. Anyways, the bat, yes. Mr. Mike.
Birds are related to dinosaurs.
They are. Good job. You're getting there.
Okay, keep going.
Keep going? Okay. The wings of a bat are actually very similar to birds. They both will obviously help the bird fly, and they're not many species have that. That's why they're one of the most iconic examples of comparative anatomy. Genetics is our next main evidence. Would you like to go into genetics? No. Are you sure?
I'm pretty sure dinosaurs have nothing to do with genetics.
Actually, they might be with
No.
Dinosaurs. Are you sure?
Don't touch Willie.
Willie.
Yep, that's his name.
Bum Bum?
No,
Just Willie.
Okay, go.
Genetics is the most powerful evidence for evolution. It is the study of gene sequences show how similar many organisms are. Like now, example of genetics is. Sorry about that, everybody. I interrupted Mike. Mike was coloring, and I interrupted him. Here's Willie. I'm sorry. What I was saying before was they took a swab from the father's mouth, from the father's cheek, and from the baby's cheek, and they'd compare the two cells, and using genetics, they'd know that he was in fact the father of the baby, because the same exact genetics, and the same exact genes. Most closely related organisms have higher percentages of identical gene sequences than those than more different, obviously. And a fun fact for you is that we humans, not dinosaurs. I'm sorry. Oh God. We humans are only 1.5% different from chimpanzees. So yes, that is why most people think that we come from chimps or apes, because we most likely probably did at one point. Could we go to commercial now, please?
Only the best make our famous 2 for $20 menu, like the new creamy Cajun steak and shrimp pasta. A great deal for game day or every day. See you tomorrow.
Oh, we're back for break. How about that already? Mike, how is your dinosaurs coming?
I made Willie too, because you
Really, too.
you made Willie 1 go by.
I'm sorry. I'm sorry about that. Can you apologize for? How about we just go back to Larry for evolution, and to wrap that up, and start natural selection. Please hurry, please.
Hello, Larry, back here at the studio. I'm here to talk about natural selection. What is natural selection? Well, natural selection is driven by mutations, which are mistakes in the genes. And sometimes there are good mistakes, which allow the organism to keep reproducing. But also there are bad mistakes, which make the organism eventually die out and become extinct. An example of a bad mistake is probably sea turtles on a beach. When they are hatched onto the beach, they actually, all the little babies try to reach the water, but most of them don't even end up reaching the water because they end up getting eaten by giant seagulls, and that's how they die out. And they actually are getting very close to become extinct. They're, what's that word I'm looking for? Endangered. They're an endangered species, and that's part of natural selection. So, back to you guys at the studio.
We're back, everybody. This is one weird news show. And like, especially that Larry guy. We don't know what happened to him. Yeah. He's one weird guy. Kind of like my mom. Yeah, my mom. That's what I was gonna say. Just keep drawing, Willie. Yes. Natural selection. Natural selection is driven by mutations, which are mistakes in the genes of cells, and mistakes aren't always bad. They can be a good thing. For good things, they can make the species, or that at least that organism, stronger, bigger, faster, or prettier, like me. And maybe even the ability to blend in more, like camouflage or something. And as they reproduce, these good genes will be passed on to evolve the species. But if say for example organism had bad genes, then nothing would want to reproduce with it, and the bad genes would die off, making the popular saying, survival of the fittest, which the best genes are passed on to make the best species. We're back, everybody, and time to wrap up the show. I hope that you really enjoyed this this video, I guess, or this news channel 8. I hope. I don't know. Come on, I'm already 7. I'm already losing my job. Come on. I hope you learned a lot about evolution. Okay.
And dinosaurs.
Then no dinosaurs. Okay. You know what? No dinosaurs. No more dinos. Okay, Mike? Huh? Yeah.
Alright.